we're going to be using Gizmos to understand periodic trends a bit better. We're going to be going over atomic radius, ionization energy, and electron affinity. So we'll see how all three of these items are interrelated and how they are influenced by the subatomic particles, which are electrons, protons, and neutrons. To start off this assignment by answering some prior knowledge questions, we're going to be comparing image A and image B. We have two magnets that are the same size, on top of two books that are a different size, and beneath the book are two paper clips that are each the same size. So in this situation, we want you to make a prediction for questions 1 through 3 by comparing images A and B. So this is an analogy to electrons and atoms and the pull that atoms have on electrons. So try it out. So in this portion here, what we want to do is get the size of the radius of hydrogen. All right. So the way that we do this is by clicking on this item here. So we're going to show the ruler. We're going to drag one end of the ruler to the center of the atom and the other end of the ruler to our valence electron. So we only have one electron here in the outer ring. Well, we only have one outer ring or one energy level. So we measure this distance and it is 53 picometers. So we're going to go ahead and write that out. Then we're going to do the same for lithium. So we're going to go down and click on lithium. Notice our ruler is already in the center of the atom. We're going to drag the other end across to the valence electron, and this is going to measure the radius of the atom, and we already have our ruler selected, and that's 167 picometers. And you go ahead and write that out. So anyways, please go ahead and make your prediction here for the trend of the radius of the atoms as you go down this group. So will they increase, will they decrease? Figure it out. Then you're going to want to write out the number of energy levels for these different atoms along this group, and you're also going to write out the atomic radius. So notice the energy levels are the same as the number of rings. So please go ahead and fill that out for this section here. Keep in mind this entire section here up to number 5 relates to the group. But now we're going to focus on the period, specifically period number 3. So period 1, 2, 3. And now we're going to work on these atoms here. So we're gathering the same data. We want the energy levels and the radius of the atom. In addition to that, we also want the number of protons. So please make sure you gather your data using this information here. I want you to write out your observations and do a little exploration on your own. So to select other periods on the periodic table, you're going to go ahead and select your other periods by clicking on other atoms in the group. So we go down a period, we keep going, and you're going to keep on clicking on these to get more information. So now we're looking across the period, so we're trying to see, are there more energy levels added as we go across the period? So remember the number of rings, that's for 10A. Now focusing on what happens to an element if we gain or lose an electron, specifically by selecting an icon that says show ion. We're going to either show ion and then remove it to see what the difference is. So we go from sodium to sodium ion, which is Na+, and try to see what the difference is, specifically with the electron. Then you're going to do the same thing with chlorine to form a chloride ion. For activity B, we're going to focus on ionization energy. Keep in mind, ionization energy is the energy needed to remove an electron. Please make your prediction and then start this investigation. So to perform this investigation, we're going to focus on group 1 from hydrogen all the way to francium, and we're going to do the same thing for period number 3 from sodium to argon. In this situation, we're going to click atomic radius, switch it to ionization energy, and what we're going to do is that we're going to drag our atom towards this positive symbol, and then we get a measurement. So this is ionization energy. This was the energy needed to remove one electron, or our valence electron, from hydrogen. And remember, the valence electron is the outermost electron on an atom. We're also going to show our ruler to measure the distance from where our electron was ejected to where it was received. So we want to record our units and our ionization energy. You're going to be doing this for all the other atoms in the same group, and then you're going to do the same thing for period number 3. Make sure to answer the questions numbers 3, 5, 6, 7, and 8. Question number 9, we're going to start measuring electron affinity for the different atoms for an atom to attract an electron. For question number 9, we're going to start measuring electron affinity. This is an atom's ability to attract electrons. Keep in mind that the more negative the number, the stronger the attraction is. So we're going to start off by measuring hydrogen. This will be a practice. So let's select electron affinity. We're going to hold onto our atom and drag it to the right, and we're going to pull that lone electron on that red positive symbol. Now we measure the electron affinity, and we're going to show our ruler and measure the distance that that electron traveled. And go ahead and do the same for fluorine. Keep in mind that fluorine is in group 18, period number 2. So let's click on lithium, and there's fluorine, so try it out. And make sure you record the distance and the electron affinity. For question number 11, you're going to only gather the data for electron affinity for all of the elements in group 17 and period number 2. Then you'll use that data to answer the questions below. Now we're going to use our Gizmos to view all of this data in an easier way. But we're going to click on Trends, and here you're going to be clicking on atomic radius, ionization energy, and electron affinity to view these different trends. In addition to that, you need to understand that there are metals and nonmetals, so please keep that in mind as you answer the final questions.